Hey everybody, I just wanted to spend a little bit of time going over question 16.71 in Brown-Lemay-Burston. And this is a question where we are going to use KB to determine the pH of the solution. And this problem is primarily straightforward, not to say that it's not going to be long or easy, but it's definitely straightforward in terms of determining the pH of the solution. So the first thing that we want to do is write a reaction for this. Remember, the hydrogen, when it's a compound with a nitrogen in it, is going to add to the nitrogen, so that's a plus, kind of like ammonium and ammonia. So now that we have this reaction, okay, I mean, this is in essence, if we look at it like this is B plus H2O is in equilibrium with the base with a hydrogen tacked on plus OH minus. Okay, that's the general equation that we use all the time. But in order to do this, we want to solve, we want to use an ICE chart, and we can go, and then we can go from there. So let's do an ICE chart for this. Okay, and then the original concentration of the ethylamine is 0.075. So the base is 0.075. We don't care about the water. The water is going to not play a role in the equilibrium. Not to say that it's not part of the reaction in the stoichiometry, but just water doesn't play a role in the equilibrium typically. And so then the products are going to be 0 here. So in order to determine the pH, we need to solve for this part of the ICE chart. We need to find the hydroxide ion. From the hydroxide ion, we can find the hydronium ion and calculate the pH. Or we could find the POH and then calculate the pH. So, knowing that this is weak, now we can finish filling in our ICE chart. Remember that if it's a reactant, we lose it, and if it's products, we gain it. So this is going to be minus x, and this is going to be plus x and plus x. There's no stoichiometry that we have to worry about. Notice that all of these are 1 to 1 to 1 ratio. Okay, normal base problems are 1 to 1 to 1 ratio. And so at equilibrium, this is going to form 0.075 minus x, and this is going to be x, and this is going to be x. That doesn't get us the amount of hydroxide ion, but we're getting close. So now we need to have the Kb. 6.4 times 10 to the minus 4, let me double check, yep, equals the products, x times x, over the reactants, 0.075 minus x. And we can get rid of this because of the 5% rule. And now we solve for x. So we multiply by 0.075 and take the square root. And when we do that, we get x equals 0.00693. Okay, now that is not the answer. That is the concentration of the hydroxide ion. So the concentration of the hydroxide ion equals this. Okay, let me double check, because this is, I would suggest you double check anytime you have a problem, is to see what it's asking for. It says calculate the pH of this solution. So to calculate the pH of this solution, when it's 0.0693, what we can do is we can find the POH, and so we do the negative log of that, and we get the POH is equal to 2.16. So that means that the pH is going to equal 14 minus the POH, which then means that the answer is 11.84. And so there is your pH of that solution. Have a great day, everybody.